Hello again, everyone. We are now on our last topic in Module 3. This time, we will discuss systems of nonlinear equations in two unknowns. I am Catherine I. Merca from the Department of Mathematics and Statistics. We hope that at the end of this lecture, you will learn how to solve systems of nonlinear equations in two unknowns. When we say systems of nonlinear equations in two unknowns, we talk about a system of equations which contain at least one equation that is not linear. And the solution to this system is an ordered pair of real numbers that satisfy both equations. Here are some steps in solving nonlinear systems using substitution method. Solve one of the equations for x or y. If the system contains a linear equation, use the linear equation to solve for x or y. The second step is to substitute the resulting expression in step 1 to x or y in the other equation. Then, solve the resulting equation in step 2. Next would be to substitute the value in step 3 to the equation obtained in step 1 and solve for the unknown. Then verify your answer. Now, in solving nonlinear systems using substitution method, we have here the first example. You're asked to find the solution set of the system y squared equals 2x minus 1 and y equals negative x plus 2. Here are the steps. Again, if you recall, we have the first step here is to solve one of the equations for x, and if the system contains a linear equation, use the linear equation to solve for x, or whatever the case may be, solve for y. So in this case, we have the second equation is a linear equation already. If you take a look, we have here second equation is y is equal to negative x plus 2. So solving for x from y equals negative x plus 2, we have the following. X equals 2 minus y. And then substitute the result to x or y in the other equation. So we substitute x equals 2 minus y into the first equation. Thus, from y squared equals 2x minus 1, we have y squared equals, take a look, we substitute x here with 2 minus y. So solving further, we have the following. We can distribute 2 and come up with 4 minus 2 times negative y is minus 2y minus 1. Now for step 3, we solve the resulting equation in step 2. Note that we can easily solve the equation y squared plus 2y minus 3 is equal to 0. We can factor this and come up with y plus 3 times y minus 1 is equal to 0. So by the zero product principle, we have the following. Y plus 3 is equal to 0, or y minus 1 is equal to 0. And solving for y, it will give us y equals -3 or y equals 1. And then substitute the value obtained in step 3 to the equation obtained in step 1 and solve for the unknown value. So we use the equation x equals 2 minus y from step 1 to solve for x. Now when y is equal to -3, we have, so substitute this time y equals -3. You have x equals 2 minus y. You have -2 minus of -3. This should give us 2 plus 3, which is equal to 5. Hence, we have x is equal to the value 5. Now, this corresponds to the ordered pair 5, -3. So that when y equals 1, okay, from here, when y equals 1, we have this time x equals 2 minus y, but since y is 1, so you have 2 minus 1. So x is equal to 1. This corresponds to the ordered pair 1, 1. Now the last step is to verify your answer. So let us check if these ordered pairs 5, -3, and 1, 1 satisfy both of the equations in this system. When x is equal to 5 and y equal to -3, you can substitute value x here and the value y here. So you will have -3, the quantity squared, equals 2 times 5, our x is 5, minus 1. And notice that -3 squared is 9, and this is equal to 2 times 5, which is 10, minus 1 is also equal to 9. So that means to say it is true. Next, we make use of the other equation, that is y equals -x plus 2. And again, substitute the value when x is equal to this time when x is equal to 5, so you have minus x, so you have minus of 5, and our y is -3, so you have -3. Is this true? You have -3 equals -5 plus 2, but -5 plus 2 will give us also -3. So meaning to say, it's also true for the second equation. That is, -3 is equal to -3 is true. Now, when x is equal to 1 and y is equal to 1, let's make use again of the equation and verify. So we have here y squared. So since y is equal to 1 there, 1 squared equals 2 times 1. Our x here is 1 minus 1. Notice that this is again true. So let's check on the other equation also. We have y equals -x plus 2. So again, y is substituted here. It's 1. Then you have minus x plus 2. You have x here is 1, so minus 1 plus 2. Again, notice that this is also true. Meaning to say, the ordered pairs 5, -3, and 1, 1 are solutions to the system. Now let's have the graphical solution to visualize our solution set. So our solution set is 5, -3, 1, 1. So here's our graphical solution. Recall that the graph of y squared equals 2x minus 1 is a parabola which opens to the right. And solving for the domain of y squared equals 2x minus 1, we can actually take the square root of 2x minus 1. So that will give us y equals plus or minus the square root of 2x minus 1. And since we know that the value inside the square root should not be negative, then we can come up with the following. That is, 2x minus 1 should be greater than or equal to 0. And solving for the value of x, we will have 2x is greater than or equal to 1. And then we can divide both sides by 2 to come up with x is greater than or equal to 1/2. So meaning to say, our domain would be the value x greater than or equal to 1/2. And how did we get this, the following graph? How did we get this parabola here? We can take values for x here and substitute as long as x is greater than or equal to 1/2. Substitute to the equation and solve for the value y. And we have the following table. So when x is equal to 1/2, we will have 2 times 1/2, that's 1, minus 1. When you take the square root, that's equal to 0. When x is equal to 1, we have 2 times 1 minus 1, that's square root of 2 minus 1. That will give us square root of 1. So plus or minus 1. When x is equal to 2, we have plus or minus square root of 3, which is plus or minus 1.73. Similarly, we can substitute x equal to 3 and solve for the value of y. So you have square root of 2 times 3, that's 6, minus 1, so that's square root of 5. But square root of 5 is, this is plus or minus square root of 5. So plus or minus square root of 2.24. Similarly, this should be plus or minus square root of 7. So we have plus or minus 2.65 here. And when x is equal to 5, you have plus or minus 3. And when 6 is equal to 11, when x is equal to 6, then you will have, should be plus or minus square root of 11. So you have plus or minus 3.32. So let's take a look at the graph here. 1/2, when x equal to 1/2, you have here y is 0. When x is equal to 1, you have here x equal to 1, 1 is positive 1 and negative 1. When x is equal to 2, we have plus or minus 1.73. So this one, this is y equal to 1.73, and here when x equal to 2, this is y equal to negative 1.73. And down the line, we can also take a look when x is equal to 5 here. So when x is equal to 5, y is positive 3 here. It's positive 3. And when x is equal to 5 again, y is equal to here. If you take a look, that's negative 3. On the other hand, the graph of the equation y equals this one, this linear equation, the graph of that is taken from the following values. From these values, we have when x is equal to minus 1, we get y is equal to 3. Here, when x is equal to minus 1, y is equal to 3. When x is equal to 0, here, y is equal to 2. X is equal to 0, y is 2. When x is equal to, when x is equal to 0, y is equal to 2. When x is equal to 1, okay, y is also equal to 1. When x is equal to 2, y is 0. Here. When x is equal to 3, y is negative 1. This one. When x is equal to 4, y is negative 2. When x is equal to 5, we have y is equal to negative 3. So the intersection, if you take a look, the intersection here is at 5, negative 3, and 1, 1. Okay. This one we have 5, negative 3. This is the point 5, negative 3. And the other point is at 1, 1. Which is the solution set that we got earlier in our algebraic method. So this is the visualization of the solution set of the system of equation y squared equals 2x minus 1 and y equals negative x plus 2. So let's take another example here. Second example, we are asked to find the solution set of x squared plus y squared equals 2, y plus 2x equals 3. So the first step again would be to solve for x in either or y in either of the equations. Or if the system contains a linear equation, use the linear equation to solve for x or y. So note that the second equation is a linear equation, so that from here, y plus 2x equal to 3, we can solve for the value y, which is equal to 3 minus 2x. Okay. It's 3 minus 2x. From 3 minus 2x, we can now go to the second step. Substitute the result to x or y in the other equation. In this case, we substitute y equals 3 minus 2x into the first equation. This one, y equals 3 minus 2x, we substitute it in the first equation. So we now have x squared plus y squared equals 2. And when we substitute y equals 3 minus 2x, here we will have x squared plus 3 minus 2x, the quantity squared, is equal to 2. And then simplifying this further, we will now have, this is 9 minus 2 times 3 times negative 2 will give us negative 12x here. And this one is equal to negative 2x, the quantity squared, give us positive 4x squared. So from here, x squared plus the quantity 3 minus 2x squared equals 2. That will give us x squared plus 9 minus 12x plus 4x squared equals 2. And then we add similar terms so that we have 1x squared plus 4x squared. That will give us 5x squared. And we have minus 12x here. And then you have plus 9, you have minus 2. So that should give us the following. That is 5x squared minus 12x. 9 minus 2 is 7. So from here, we now go to step 3. Solve the resulting equation in step 2. Solve the equation 5x squared minus 12x plus 7 equal to 0. And we can factor this out as 5x minus 7, x minus 1 equal to 0. Why? Because 5x times x will give us 5x squared minus 7x and then minus 5x, which will give us minus 12x. And minus 7 times minus 1 is actually our positive 7 here. So these are the correct factors so that you now have 5x minus 7 equal to 0 or x minus 1 equal to 0. But from here, you can have 5x equal to 7, or from here we have x equal to 1. And dividing both sides here by 5, we have x equal to 7 over 5, or this time we have x equal to 1. So for step 4, substitute the value obtained in step 3 to the equation obtained in step 1 and solve for the other unknown. And then try to use the equation y equals 3 minus 2x from step 1 to solve for the value y. So when x equal to 7 over 5, you can substitute x equal to 7 over 5 to the equation y equals 3 minus 2x. That comes up to be equal to 3 minus 2 times 7 over 5 here equals, the LCD here is 5, so 5 times 3 is 15, minus we have 14 over 5, so we have 1 over 5. So meaning to say, the ordered pair, we have now the ordered pair x equal to 7 over 5, and we have 1 over 5. When x is equal to 1, we have y equals, again, 3 minus, you substitute 1 here. You have 2 times 1 equals 1. So y now is equal to 1. Again, this corresponds to the ordered pair 1, 1. So our last step is to verify whether we have the correct answer or not. So let us check if these ordered pairs 7 over 5, 1, 5, and 1, 1 satisfy both of the equations in the system. We consider when x is equal to 7 over 5, we have, and y is equal to 1 over 5, we have the following. X squared plus y squared is equal to 2. We check whether this will give us a true statement or not. So when x equal to 7 over 5, we have 7 over 5 squared. It will give us 49 over 25 plus 1 over 5 squared will give us 1 over 25. So that's supposed to be equal to 2. Why? Because we have 49 over 25 plus 1 over 25 is 50 over 25, which is indeed 2. On the other hand, for y plus 2x equal to 3, that is 1 over 5 plus 2 times 7 over 5. Again, we have the LCD here is 5, and we have 2 times 5 that will give us, so we have 1 over 5 plus 14 over 5. That's 15 over 5, but that's equal to 3, so it's also true. When x is equal to 1 and y equal to 1, we can again verify and come up with, again, 2 true statements. So meaning to say the ordered pair 7 over 5, 1 over 5, and 1, 1 are solutions to the system. Now let us take a look at the graphical solution to confirm that the solution set is indeed equal to 7 over 5 and 1, 1. So here's the sketch. Notice that this equation, x squared plus y squared is equal to 2, is actually a circle. and the equation y plus 2x is equal to 3. So recall that the graph of this equation, x squared plus y squared is equal to 2, is a circle with radius r square root of 2, which is equal to 1.4. So ang center is 0. We have a center 0 there. And this is 0.5, so 1. It's 1.5, so we have 1.4 here. It's a radius 1.4. So we're able to sketch this circle. And as for the graph of the linear function y plus 2x equals 3, we can rewrite this as y equals 3 minus 2x. And if we substitute x equal to 0.5 here, x is equal to 0.5, we get the value, this should be 2 up to here now. We're going to extend this line here, the value 2 is here. When x is equal to 1, we have y is also equal to 1. So when x is equal to 1, y is also equal to 1. When x is equal to 1.5, y is equal to 0. 1.5, so get y is equal to 0. And when x is equal to 2, y is equal to negative 1 here, when x is equal to 2. Negative 1. So notice that the point of intersection is equal to 7/5, 1/5, and 1/1. That is, we have 1.4 here. Take a look, this is 1.4. And we have 0.2, 1.4, and 0.2. And we have 1, 1. So this is 1, 1. It's at 1, 1. And this is at 1.4. X here is at 1.4. And we have y is at 0.2. This one. This point is 1.4, 0.2. And this point is at 1, 1. We can also solve nonlinear systems using elimination method. If the nonlinear system is in the form a sub 1 x squared plus b sub 1 y squared equals c sub 1, and a sub 2 x squared plus b sub 2 y squared is equal to c sub 2, then we can solve this system using elimination method, just like how we work with system of linear equations in two unknowns. So here are the steps in solving nonlinear systems using elimination method. Write the equations in the form of ax squared plus by squared equal to c, and then eliminate x squared or y squared by multiplying an appropriate number to both sides of either of the equation or both equations. Next would be to add the equations obtained in step 2. We know that this will result to an equation in one variable. Then solve this resulting equation in one variable obtained in step 3. Find the values of the other variable by substituting the value obtained in step 3 to any of the two original equations in the system. And then lastly, verify your answers. So we have here another example. Solve the system 4x squared plus y squared is equal to 13. X squared plus y squared is equal to 10. Here are the steps. First step would be to write the equation in the form of ax squared plus by squared is equal to c. So we can skip this step since it's already written in such a form. Then eliminate x squared or y squared, whatever the case may be, by multiplying an appropriate number to both sides of either equation or, if necessary, to both equations. Then denote the first equation by e sub 1 and the second equation by e sub 2. So in this case, we denoted the first equation 4x squared plus y squared equal to 13 by e sub 1 and the second equation by e sub 2. That is x squared plus y squared is equal to 10 is our e sub 2. Then we can solve by eliminating y squared. And if you take a look at the two equations, we can do this by multiplying -1 to equation 1 so that -1 to equation 2 so that we can eliminate y squared. So doing that will give us -1 to equation 2 will now be negative x squared minus y squared equals -10. So the next step would be to add the equations obtained in step 2. So this will result in an equation in one variable. So we have it here. E1 is 4x squared plus y squared equals 13. The negative of E2 will give us negative 4x squared minus y squared equals -10. So adding these two, 4x squared minus x squared will give us 3x squared. And this is y squared minus y squared is 0. What is left here is 13 minus 10, which will give us 3. And then the next step would be to work on the following. Solve this resulting equation in one variable obtained in step 3. That is, solve the equation 3x squared equal to 3. So we have from 3x squared is equal to 3, we can divide both sides by 3 to come up with x squared equals 1, or that is x is equal to plus or minus square root of 1. And to say, we have now the value for x. So find the values of the other variable by substituting the value obtained in step 3 to any of the two original equations in the system. So that we can use the equation e sub 2 x squared plus y squared is equal to 10 to find the value of y. When x is equal to 1, we make use of this. When x is equal to 1, we have x squared plus y squared is equal to 10. So substitute x equal to 1. We will have 1 squared plus y squared equal to 10. So that will give us 1 plus y squared equal to 10, or y squared is equal to, solving for this, we will have 10 minus 1. So y squared is equal to 9. That means to say y is equal to plus or minus square root of 9, or y is equal to plus or minus 3. This one corresponds to the ordered pairs 1, 3. We have 1 here. When x is equal to 1, we have the value 3. And when x is equal to -1, we have also the value here. When x is equal to when x equal to 1, we have 1, 3. Also, when x equal to 1, we have 1, -3. Now, we still have to solve for the value of y when x is equal to -1. So, from here, when x equal to -1, we have substitute again to the equation x squared plus y squared equal to 10. So -1 squared plus y squared is equal to 10. So you have 1 here plus y squared equals 10. Y squared equals 10 minus 1. So again, what do we get? Y is equal to plus or minus 3. So this corresponds to the ordered pairs. We have x is equal to -1 and positive 3 ang y, and then x equal to -1, we have -0. So lastly, we have to verify our answers. We can check if the ordered pairs 1, 3, 1, -3, -1, 3, and -1, -3 satisfy both of the equations in the system. You have to do that one by one. So when x is equal to 1 and y is equal to 3, I will leave the verification to you. But there are some values already here, so you can check this. They're both true. Similarly, when x is equal to 1 here and y is equal to -3, it will give us true values. And when x is equal to -1 and y is 3, okay, again, this come up to be true. And lastly, when x equal to -1 and y is equal to -3, we verify, we come up with the following solution, which is verified to be true also. Now for the graphical solution, take a look at the following to show that the ordered pairs 1, 3, 1, -3, and -1, 3 are solutions to the system. So let us take a look that, let us verify using the graphical method that indeed these are the solution to the equations x squared plus y squared is equal to 10, and the other, what's the other equation given earlier. So here's the graphical solution. Note that x squared plus y squared is equal to 10 is a circle with radius r equals square root of 10. But square root of 10 is 3.16. And with center at 0, 0. So this is the circle with radius 3.16. This one. Okay, 3.16. Radius is 3.16. 3.16. We know that from your senior high, you already had discussed your circle and your ellipses. But if in case you are not yet familiar on how to sketch your circle and your ellipses, there will be a lecture also discussing on this topic. So, but anyway, this is just a visualization of the result that we get earlier. So this ellipse, for this ellipse, which is the graph of 4x squared plus y squared is equal to 13. This is an ellipse with center at 0, 0. And this can be rewritten in the following form. It is x squared plus y squared over x squared over b squared plus y squared over a squared is equal to 1. And since our equation earlier is 4x squared plus y squared is equal to 13, Then we can solve for our B here and for our A. That is, our A here is equal to 13 here, which is 3.6, and our B is equal to square root of 13 over 4, which is 1.8. So that when we graph that one, we will have our value for the vertices of V sub 1, 0, 3.6. If we take a look at this one, we have our major axis is on our y-axis, where x here is 0 here, so our V sub 1 is at this point 0, 3.6, and our V sub 2 is at 0, negative 3.6. And then our covertices are as follows. We have W sub 1 is at 1.8, x is 1.8, and y 0, and we have negative 1.80. So our aim is just for you to visualize the solution set or the points of intersection. These are the points of intersection here, this one and this one. And according to the solution that we had earlier, we have the following. These points are the point 1, 3. So you have x is equal to 1 and y is equal to 3. This is the point 1, 3. This one. X equal to 1, y is equal to 3. And the point 1, negative 3. So this is the point 1, negative 3, this one. And the point negative 1, negative 3. So from here you have negative 1, negative 3 here. That's the point. And the point negative 1, this is the point negative 1, negative 3. And this is the point here, negative 1, positive 3. So we have 4 points of intersection on these two equations. That is 4x squared plus y squared equals 13, and x squared plus y squared is equal to 10. Again, the sketching of your circles and your ellipses, as well as other conic section, will be discussed later. So we just made this visualization so that you will see the solution set, or the point of intersection in this case. For our summary and conclusion, in solving one linear equation and one quadratic equation, it is always possible to use substitution by solving the linear equation for one of the variables. Now, if the nonlinear system is of the following form, that is ax squared plus a sub 1 x squared plus b sub 1 y squared equal to c sub 1, a sub 2 x squared plus b sub 2 y squared is equal to c sub 2, then we can solve this system using elimination method, just like how we work with system of linear equations in two unknowns. So sometimes the solution can be simplified by writing the equations in standard form, although it is usually the general form which is more convenient to use in solving systems of equations. Moreover, standard form is best for graphing. So for our references, we have Bleacher College Algebra, Stencil's 5th edition, Algebra and Trigonometry from the Department of Mathematics and Statistics. And we also have here the teaching guide for senior high school pre-calculus. I made use of them in taking note on the graphs that we had earlier, the circles, the ellipses, and the lines. So if you are not familiar with the sketches, you can take a look at this teaching guide for senior high school. This is available online. So this ends our topic for our session on Module